Hello everyone, let me introduce myself first. I am Pijush Sir. I completed my engineering in 2015 from Assam Engineering College, and then I did my masters from IIT ISM Dhanbad. So currently I have been teaching mathematics engineers for last 3 years, and I have total of 7 years of experience in my teaching careers. So in today's class, we are going to study a new kind of numbers, that is complex numbers. So let's start. Complex number. So till now you all have been studying different kind of numbers from class 5 to class 10. So let us recap those numbers and then we will come to what a complex number is, how can we identify a complex number, and so on. So initially when we started learning about numbers, we learned about a number called natural number, where you have the numbers like 1, 2, 3, 4 till infinity. When you add a 0 to these numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8 and infinity, these numbers become your whole numbers. Then if you include the negative numbers along with the whole numbers, negative numbers like 1, 2, minus 1, minus 2, minus 3, minus 4, minus 5, together all these numbers become your integers. Now there are other kind of numbers as well, like all the numbers that can be written in P by Q form, numbers like 3 by 4, 7 by 9, all these kind of numbers. If we include everything from natural number to the numbers which can be written as P by Q form, these all numbers together becomes your rational number. Rational numbers. And then you have other numbers like pi, then root 2, root 3. These numbers cannot be written in P by Q form, and all the numbers that cannot be written in P by Q form are called irrational numbers. And together the rational and irrational numbers constitute the numbers called the real numbers. Real numbers. Till now we have studied all about the real numbers. In your class 5 to 10, all the syllabus you have studied about all the real numbers, including the natural, whole, integers, irrational, rational numbers, and all these numbers together are called real numbers. But in today's class we will study about complex number. This complex number is nothing but amalgamation of real numbers plus imaginary number. So what is imaginary number and why we need imaginary number, we will have to understand that first, and then we will come to what and how we can constitute a complex number. So we will first understand what is the imaginary number and why we need a imaginary number, and then we will study about real numbers plus imaginary number, that is called complex number. Complex number. So let us go back and try to understand what is imaginary number. So first of all, to understand imaginary number, we have to first know. I know you already have studied about quadratic equation, but I'll again discuss few things about quadratic equation. Then only you can understand what a imaginary number is and why we need imaginary number. So in your class 10 syllabus, you have studied about quadratic equations, right? So quadratic equations are the equation of the form ax square plus bx plus c equal to 0. So we were able to solve quadratic equation from different method, but when you think about it, the formula we used to solve a quadratic equation was roots of a quadratic equation can be written as minus b plus minus b square minus 4ac divided by 2a, right? I think you guys remember very well that the roots of a quadratic equation can be calculated from this formula. So if you go back again and try to understand what this b square minus 4ac under root over is called, it is called the discriminant of a quadratic equation. So when I hope you, again I am very much stressing about this fact that I hope you guys remember what is a discriminant of a quadratic equation. If you don't, I am repeating, this discriminant of a quadratic equation will determine how and what kind of a root a quadratic equation will have. So first of all, if this b square minus 4ac is greater than 0, it will give you two distinct roots. You will get two distinct roots when b square minus 4ac is greater than 0. If b square minus 4ac is equal to 0, the roots of that quadratic equation will be equal. Both the root will be equal roots. That means if you are getting something like this x square is equal to 4, then the roots are roots can be plus minus 2, or anything that has b square minus 4ac as 0 as a discriminant, the roots will be equal roots. Okay, so we got b square minus 4ac which are greater than 0, then we will be getting two distinct roots. When b square minus 4ac is equal to 0, we will be getting two equal roots. And there is another condition, when this b square minus 4ac under root over b square minus 4ac is less than 0. So think about it. When b square minus 4ac is less than 0 and you put it inside a root over or under root, when you are putting, suppose you have b square minus 4ac is equal to suppose minus 4, can you calculate the value of minus 4 from your real numbers? Whenever we get anything under root over as negative, we always tend to say before today's class that this is not possible, impossible or not possible. But from today onwards, we will have something which can describe anything that has a negative under root over, and that is how the invention of imaginary number came in. So the scientist or the mathematician, they felt like we need something to describe this kind of a number. So for that, to describe anything that has a negative sign under root over, this mathematician called Euler, he invented the imaginary number. So what is an imaginary number? I will come to it, but the reason behind the invention of imaginary number is this mathematician, they wanted something to identify or to represent a number which has a negative sign under root over. To represent that number, they have invented or they have discovered this imaginary number. Okay, so how we represent anything like this number, like negative minus 4 or negative minus 2 or negative minus 100, whatever may be the number, how we will represent, we will learn about that in a little bit. So this Euler, mathematician Euler, he stumbled upon a equation and started thinking. The equation was very simple, x square plus 1 equal to 0. This was the equation and he wanted to solve this equation. So how will you solve this equation if you want to solve? So x square become minus 1, x become root over minus 1. in real numbers, in real terms, there is no solution for this. But when he was trying to solve this, what he did was, he described negative minus 1 as I, and it is called iota. From this itself, the invention of imaginary number started. So when you find anything which has a negative minus 1 component to it, you will name it or term it as simple as I. So for example, you have x square is equal to minus 4. X become root over minus 4. So what I will do is, I will divide this number into two parts, 4 into root over minus 1. So I know root over minus 1 is nothing but I. So I will write root over 4 I, or I know what is root over 4, it is 2 or plus minus 2, whatever you want to write. So it becomes 2I. So this is nothing but a imaginary number, because there is no real component to it. It is only imaginary. We imagined minus 1 as I, and we replaces the minus 1 as I here, and the number becomes 2x is equal to 2I. This is how the imaginary part of a real number comes in. Okay, so we understood a imaginary number. For example, again, if you have a number like minus 36, so you want to write it as an imaginary number. How will you write it? X equal to minus 36, x, I will write minus 36 minus 1. So 36 minus 1 I will term as I or iota, and it becomes 36, I know, plus minus 6. So x become plus minus 6I. This is the imaginary number I was talking about. We got what? The imaginary part of a real of a complex number, and then we already have the real part of a complex number, and together both number becomes the complex number. So now we will come to the whole complex number as a whole, where we have the real part and we have the imaginary part. We got the imaginary part from the quadratic equation itself, and then real part will come from our real numbers. So any number that has a real part and the imaginary part together, it is called a complex number, and complex number are denoted by, complex number are represented by, complex numbers are represented by the capital letter Z of our English alphabet. So if you have a complex number Z, in general, the general representation of a complex number is A plus IB, where A is called the real part of the complex number, real part, and B is called the imaginary part of the complex number, and together both becomes a complex number. Got it? For example, there are few, I'll write few complex numbers. Suppose you have Z1 equal to 3 plus 4I. Again you have Z2 is equal to 7 plus 9I. These two are called the complex number. Simple complex number where the real part will be this 3. If you are being asked what is the real part of this complex number 3 plus 4I, the real part will be 3, and the imaginary part, it will not be 4I but the 4. Imaginary part is 4. So real part is 3, imaginary part is 4. Imaginary part is the number which is attaching along with the iota, that is the imaginary part, and the number which is alone in the complex number is the real part. So it is very important. You might be facing some questions related to the imaginary real part. Okay. So this is how a complex number is described or represented. Can be represented as Z, Z1, Z2, Z3, Z3, Zn, and it can be written as the real part and then imaginary part. So we are done with the complex number, introduction to complex number part. So in the next part of this class, we will learn about how to do the general algebraic functions or general algebraic operation of a complex number like addition, subtraction. So these are, as we did for the real numbers, we can also do for the complex number the normal algebraic operation like addition, subtraction, multiplication and the division part. And this is very important because you will be asked to do all these operations in your exams or in your next chapter of the complex number.